Okay, let's just dive right into this. Welcome to today's explainer, where we're looking at a genuinely clever little tool that just hit version 0.1.1. It's called codewiki-cli. It's a brand new Rust-based command line interface, and honestly, it's fundamentally changing how our AI coding agents interact with documentation. I mean, if you've been relying on LLMs to help you code, you already know the drill, right? Hallucinations happen when they don't have enough context. Getting them that context, that's half the battle. And this tool tackles that exact problem head-on.
Right off the bat, we're dealing with a massive bottleneck in software development right now. Think about it. As humans, we love reading wikis in web browsers. We click around, we look at nicely rendered HTML, it's great. But our agents, they don't work like that. They desperately need standard input, standard output, and clean, raw Markdown. When we force an LLM agent to essentially navigate a browser, or worse, parse raw HTML just to find some architecture docs, it's painfully slow and incredibly clunky.
So, let's get into Section 1, the context bottleneck, and exactly why these agents struggle so much.
You see, when agents try to read a GitHub wiki using traditional web scraping methods, they just get completely bogged down. They can literally waste minutes processing thousands of lines of raw HTML, nested divs, weird CSS styling tags, all just to extract like a single design rationale. It's a massive waste of processing time and, crucially, context window space. I mean, dealing with a giant DOM tree is miserable enough for a human developer, but for an LLM, it's a token-consuming nightmare. They aren't built to be web browsers, you know? They're built to process text.
Which brings us to Section 2. Enter codewiki-cli, the missing translator. Now, the really crucial detail here is that CodeWiki actually has no public API whatsoever. Nothing. So the developers stepped up and built codewiki-cli as this missing translator. It's written in Rust for that high-performance edge, and it securely steps in to act exactly like the web frontend does. It speaks directly to Google's internal batchexecute remote procedure call. That means it completely bypasses the need to ever open a headless browser or hack together a scraper. It takes this highly complex task of reading a wiki and boils it down into one single seamless command.
Moving to Section 3, reverse engineering, and how it bypasses that whole no public API issue.
Because there's no official API, CodeWiki actually reverse engineers the web front-end's RPC calls. Specifically, it targets two undocumented under-the-hood endpoints. The first one is VSX6UB, that's VSX6UB for the spelling, and that one returns the entire wiki for a repository as structured JSON. Honestly, this is the exact same call the server uses to render the page for our human eyes. The second endpoint is EGXFE, EGIXFE, and that's used to answer chat questions via Google's Gemini. By hooking into these directly, CodeWiki pulls the raw source without needing any authentication for public GitHub repos. It is just a brilliant hack that skips the middleman entirely.
Let's look at Section 4, the three core commands: structure, read, and ask.
So how does an AI agent actually interact with this architecture in practice? Well, it pipelines incredibly cleanly into agent workflows using three logical steps. First up is structure. This returns a flat list of section titles, which is absolutely perfect for high-level discovery before the agent dives deep into the weeds. Second is read, which fetches the full wiki content. And third is ask, which lets the agent query Gemini against the wiki content in natural language so it gets direct answers with citations. It mimics exactly how a human developer would research a new codebase, but, at machine speed.
Now, what's super interesting here is the read command. It's particularly powerful because it doesn't just, dump a bunch of raw text. It actually post-processes the output, so it's absolutely perfect for LLMs. For instance, it rewrites relative wiki links into absolute URLs so your agent doesn't get lost trying to follow a dead path. Even better, and this is a really brilliant touch, it extracts embedded GraphViz diagrams and spits them out as fenced.code blocks right after their section. That means an agent can literally read the architecture diagram's logic natively. Oh, and it also prints a clean header line so the agent always maintains its context over long multi-turn conversations. It's the little things, right?
All right, Section 5, built for AI agents, specifically looking at agent integration.
Now this number right here, 6, is actually surprisingly important. It represents the 6-hour disk cache for the bootstrap session. See, when an agent gets into a loop of querying documentation, you absolutely do not want it waiting around for a fresh network setup every single time. Every millisecond counts. Because of this 6-hour cache, which sits neatly in your system's cache directory, back-to-back invocations completely skip that initial bootstrap GET request. It makes subsequent queries ridiculously fast and just totally removes a major speed bump.
Right out of the box, this tool ships with a ready-to-install Claude Code skill.
You just drop it right into your skills folder, and Claude automatically knows exactly when to reach for CodeWiki. Add in that aggressive caching we just talked about, plus 0 required authentication for public repos, and you have a totally frictionless tool. It's basically plug and play for your local AI developer. But take a look at that last point regarding TLS, because it solves a genuinely huge headache.
This is a super fascinating architectural choice. TLS certificate verification is actually disabled by default. Why? Well, monitored enterprise agent sandboxes frequently use TLS intercepting proxies, and these proxies present certificates that don't chain to a trusted root authority. If strict verification was left on, every single request inside the agent secure sandbox would just crash with this opaque, frustrating error. So disabling it by default keeps the request flowing. It stops the agent from failing silently. Though obviously you can easily toggle strict checking back on with a simple environment variable if your specific security posture requires it.
Okay, final section. Section 6, the bottom line. Getting context in milliseconds. By moving from a human-native web format over to an agent-native pipeline using standard output, we are completely transforming the workflow here. We're slashing the time it takes for an AI to get repository context, going from literally minutes of fighting with HTML tags and unstructured data straight down to mere milliseconds to receive clean, highly composable Markdown. It is a night and day difference in performance, and that directly translates into much faster, way more accurate code generation.
It's not a wiki replacement. It's a wiki reader built for the way coding agents actually work. This quote from the release notes pretty much perfectly summarizes the whole mission of the project. It seamlessly bridges that huge gap between GitHub's unstructured, messy wikis and your agent's highly structured workflow. It just embraces the fundamental reality that agents absolutely need standard input, standard output, and Markdown to function at their absolute peak.
Which brings us to our final thought for today's explainer. With tools like codewiki-cli making context retrieval this incredibly fast and frictionless, that old excuse of LLMs not having enough context is rapidly disappearing. So it's time to ask, are you truly giving your AI the documentation it needs to succeed, or are you still forcing it to read the web like a human? Thanks so much for joining me today, and I really highly encourage you to test out codewiki-cli in your own agent workflows.